All right, today we're recording power functions, and we're working with some things. Some of the things we're doing are going to seem pretty easy, and some of the things we're doing are going to seem a little bit more difficult. The concept of a power function is simply something we've probably seen before a bunch of times. Y equals ax to the b. The only difference, what we're going to be doing today, is b frequently is going to be things that are rational, like 3/4 or half or something. So that's going to look a little bit different. Composite functions, I'm going to talk about that later when I can show you an example, but essentially it's taking a function of a function. So it kind of all works together. So we'll get to that in the latter half of the lesson. Let's take a look at the operations of functions. We'll have f of x equals 3x and g of x equals x plus 3. This is all going to seem fairly simple. If I asked you, if I said to you h of x equals f of x plus g of x, you would just take whatever f of x was, which happens to be 3x, and add it to whatever g of x is, which happens to be x plus 3, and you would get 4x plus 3. You're just adding those things together. If I asked you to subtract them, again, you're just going to do 3x minus x is 2x. Don't forget that negative goes whoop over here to the 3, and that becomes a minus 3. If I asked you to multiply them, same deal. You would just take whatever the function was and multiply them together. 3x times x, 3x squared, 3x times 3, plus 9x. And if I asked you to divide them, 3x over x plus 3. And nothing real fancy about any of that stuff. The one thing you do need to know is that the domain of H consists of x values that are in the domains of f and g. The domains, meaning the x numbers, have to work in both f and g. And the only time we end up with problems with domains is when we have something on the bottom. So if we look at this one right here, the domain of x, the domain of h, x cannot be -3 here because it cannot be on the bottom. So that is an immediate issue that you see. Additionally, the domain of a quotient does not include x values for which g of x is 0. And that's what we're just talking about. Right here, the g of x being the quotient, the division problem here, g of x can't be 0 if you're going to put it in there. So those are the two domains that you have to be concerned with. So we're going to kind of quickly go through a couple of these if we're just adding and subtracting. If we add f of x plus g of x, we have 3x to the 1/2 power plus -5x to the 1/2 power. Well, that just becomes -2x to the 1/2 power. And even if it's to the 1/2 power, you treat it just like it's x squared. So if I said 3x squared minus 5x squared, it'd be -2x squared. No different. If we're subtracting them, well, then this just becomes 8x to the 1/2 power. Pretty simple stuff. Nothing too fancy. And functions of f and g each have the same domain. Well, what can x not be in this situation when we have x to the 1/2 power? Well, x cannot be a negative number because remember, 1/2 power, it means square root of x. And so you can't have the square root of a -5 or something like that. And so what we're talking about is the domain being positive reals. Okay, positive reals. That's shorthand for positive reals, but we'll write it out positive real numbers, or really non-negative. I guess you can have a 0 there too. So if the domains of f plus g and f minus g have to be consistent with what the domains were of the others, we're still talking about all, and here we're going to say non-negative reals. All non-negative reals. And so let's take a look at example 2 when we're multiplying. And then remember that division one, that's where the domain thing probably is more prominent. Here in the A's, when we multiply f and g, if f is 7x and g is x to the 1/6 power, when I multiply them together, if I were multiplying x squared times x to the 5th, we would all say, oh, that's x to the 7th. You add the 2 and the 5. Well, same thing here. I have 7x to the 1st power, and so when I think about when I multiply them together, well, 7 times 1 is just 7. And then I have x. Well, this is x to the 1, but 1 plus 1/6 is 1 and 1/6. Instead of calling it 1, I'm going to call it 6/6 plus 1/6. And so we're going to have 7/6 power here. So 7x to the 7/6 power is what I'm going to have for A there. F of x divided by g of x, well, if I have 7x divided by x to the 1/6 power, well, that's a root on the bottom, so that's going to be an issue anyways. But I'm going to call this 6/6, and what we're going to do is we're going to do 6/6 minus 1/6, and we're going to end up with 7x to the 5/6 power. 5/6 power. The domain in this situation, the domain consists of f is all real numbers. And a way to do all real numbers shorthand-wise is to do that double line, kind of like you do a paragraph. But the domain of G is all the non-negative reals. So we're going to put the non-negative reals there. Double line, non-negative reals. So the domain of f times g has to be the most constrictive of the two. One's all reals, one's non-negative reals, so it's got to be the non-negative again. Double line, like that. That says reals right there, reals. Because g of 0 equals 0, the domain of f over g is restricted to, and you see this f over g, I can also not have 0 on the bottom here. So I can't have all non-negative reals. I can only have the positive reals. Non-negative would include 0. We cannot include 0, obviously. All right. So you guys do a checkpoint. You add and subtract and multiply and divide all those things. And then tell me what the domains were for each one. Go ahead and pause it and work on it. All right. Welcome back. F plus G, if I got these two things, they have the same powers, which is nice. So part A here is 3x to the 3/2 power. All right. And the domain of that thing, because it's to a half power, can't have negatives in there. So I'm going to have non-negative reals on this one. Double line, non-negative reals. On the B, when I subtract them, it's a very similar situation. 5 minus a negative, well, that ends up being 7, because minus a negative ends up being a plus. And same thing, non-negative reals. For C, when I multiplied them together, 5 times negative 2 is negative 10, and I added 3/2 plus 3/2, which gave me 6/2, or just 3, so I end up being x cubed. But because they were to the 1/2 power in the beginning, I have to have that non-negative reals again, even though negative reals would fit in here. And for the D, when I divide them, because the same things, the top and the bottom, I'm just going to end up with 5/2, because the 2x to the 3/2 cancel each other out there. And so it's just 5/2. However, I could not have 0 on the bottom of that fraction. I also couldn't have negative numbers. So I'm just talking about positive real numbers here. All right. Let's move on to some harder stuff, some composite functions. When I describe composite functions, I always talk about barracudas. If I want to increase the number of barracudas I have in a pond, I have to have more bass for them to eat. If I want to increase the number of bass, I have to have more shrimp or something smaller than bass for them to eat. So if I really want to increase the number of barracudas, I increase the number of small fish, which are eaten by the next size fish and which are eaten by the barracudas. And so that's kind of like a composite function. I don't know if that makes any sense to you at all, but let's see. The composite of a function g with a function f is g of f of x. That's what the composite function is going to look like. The domain of h is the set of all x values such that x is in the domain of f and f of x is in the domain of g. So that's going to get a little sticky. So let's take a look at example number 3 here. In example number 3, we are trying to find part A, f of g of x. So when I do f of g of x, instead of x right here, I'm going to put 3x plus 5 because that's what g of x is. And f of x is doing this to the x number. 6 multiplied by whatever you have here, 3x plus 5, to the negative 1 power. And so that's right where the x went. If you kind of see that's the x, and now the x is g. It's 3x plus 5. Well, what's going to happen with that negative is all that's going to move to the bottom. So it's going to become 6 over 3x plus 5. All right? If I'm finding g of f of x, right here in the g of x, instead of g of x, I'm going to put g of 6x to the negative 1. 6x to the negative 1, because that's what f of x is. And so what I'm going to have is 3 times 6x to the negative 1 plus 5. Well, what happens when I multiply those together, I get 18x to the negative 1 plus 5, which equals 18 over x plus 5, because that x to the negative 1 moved to the bottom. If I want to find f of x, that means do it the same thing twice. F of x is 6x to the negative 1, and so if I do 6 times f of x, which is 6x to the negative 1, and then that thing's to the negative 1. I'm going to change my ink real quick here, so we kind of separate those two questions a little bit. I'm going to take the negative to the 6 and to the negative 1, and what happens is I'm going to get 6 times 6 to the negative 1 x. So negative 1 times negative 1 equals x. Well, these two things right here, 6 and 6 to the negative 1, are going to cancel each other out and leave me with just x on question C there. On D, it says the domain of f of g of x. Well, let's look. What domain regulations do I have? On f of x, I can't have 0, but everything else is good, and g of x is good. So the domain of f of g of x consists of all the real numbers, but what can I not have? Well, in the end, I couldn't have negative 5/3 is what would make this thing right here not work, negative 5/3. And so that's just the composite part of it. All reals, but not negative 5/3. Because g of negative 5/3 would equal 0. And that can't have 0 on the bottom of that fraction, right? It's not in the domain of f is what you want to say right here. Domain of f. Meaning f of 0, meaning that f of 0 would get me 6 over 0, which would be a problem, right? Obviously not defined, undefined right here. Undefined, all right? The domain of g of f of x and f of x consist of all the real numbers except for 0, because remember you can't have 0 on that f of x, because 0 is not in the domain of f. All right. So let's take a look at that checkpoint real quick. You guys work on that for just a moment, and then I'll give you the answers. We can talk about it tomorrow. All right. F of g of x is what they want us to find first. So if I do f of g of x, and g of x is 3x to the negative 1, that is going to be 5 times 3x to the negative 1 minus 4. Well, 5 times 3 is 15. X to the negative 1 goes to the bottom, 15 over x minus 4. And if I find g of f of x, g of f of x is 5x minus 4. I go into my g function and I write 3 times 5x minus 4 to the negative 1 power, which equals 3 over 5x minus 4. That's easy enough. And then the last one, part C, is f of x. Well, f of 5x minus 4 is going to be 5. And what's my new x number? 5x minus 4 minus 4, which is going to equal 25x. And then when I multiply 5 times negative 4, I get negative 20. Minus 4 is negative 24. All right. So when I look at my answers, I look at domains. What's going to give me problems here? Well, here I would have a problem if x was, let me change my color again real quick to red. Here I would have a problem if x was 0 right here. That would be a problem for me. Here I would have a problem if x was 4/5. That would be a problem. Here I wouldn't have a problem. On the original equations, the domain of g cannot be 0. So I can't have 0 for g. I could have anything else. And f, I have no restrictions. So this is all reals not equal to 0. That one. This one here is all reals except for, I'll put this over here, all reals not 0, also not 4/5. But all other reals would work. And then this one here is just all reals. All right. That's section 6-3. We'll talk about it tomorrow if you have questions. Thank you.